Hey everyone, this is your Properties of Water lesson, and this is the video PowerPoint that you will need to take notes from today. Just as a disclaimer, because I'm putting this on YouTube now, I'm going to say that this is not my PowerPoint. This is something that I found on the internet and that I plan to teach with to you, and I will not be using it for any other purpose. I will be moving through this PowerPoint pretty quickly because I have a limited time in recording. And if you need to pause it, rewind, do whatever you need to do to take your notes, then that is fine. The expectation is that you are typing notes inside of your digital class notebook. If you cannot get the digital class notebook to work on Microsoft Teams, then please just type your notes in a Word document or write them down in your science notebook or somewhere if you have them. You will be able to use these notes on your test. Okay, so I'm going to go ahead and begin. So with this PowerPoint, your essential question is, how do the unique properties of water allow life to exist on Earth? And so we've been learning about properties of water, and we're just going to make sure that we wrap things up, make sure you're good to go, and understand how water allows us to exist on this planet. All right, so here we go. So the very first thing, to understand why we're studying water, we have to understand that all life occurs in water, and basically there is no life without water. All living things require water to survive. There's water inside the cell that helps things happen. There's water outside the cell. Water is the reason that molecules such as glucose or gases such as oxygen and carbon dioxide are allowed to move through your bloodstream. Water is the reason that plants exist and why they're able to take water up their roots and provide the cell with the parts that it needs to make glucose so that you can survive. Water is everything, guys, and you need to know it. All right, so as we continue on, these properties are very important to know, especially as you get into biology next year, and then as you see down here, AP biology eventually. I'm pushing you guys to really know this material because we have the time. So our properties of water, the first one is hydrogen bonding. Second one is cohesion and adhesion. And along with cohesion and adhesion are two other words, surface tension and capillary action. Lots of vocabulary here. We will go over all of it. Water as a solvent, water being the universal solvent, meaning it can dissolve anything or mostly anything that gets put inside of it. Okay. We'll talk about hydrophilic and hydrophobic and what those mean. Expansion upon freezing is a property of water. And then its ability to moderate temperature due to its specific heat. And so we're going to go through all of these slides now. If you need to pause, go ahead. I'm going to continue on. All right, so the first property, hydrogen bonding. And so basically what hydrogen bonds are just a weaker bond that happens between molecules. In the beginning of the year, we talked about ionic bonds, where one steals electrons from the other, and they become positively and negatively charged ions. And then we talked about covalent bonds where they share. And so you can see here in the PowerPoint where you have oxygen sharing electrons with the hydrogens. And when it shares those electrons, it doesn't necessarily share them equally. Sometimes oxygen can be a bully. And oxygen takes more electrons, so it's going to be more negative. And hydrogen uses less of those electrons, so it becomes slightly positive. And so what that does is force the hydrogens on each oxygen to look for other places to make bonds. And so they create these hydrogen bonds. And that's the reason why water has most of the properties that it has. So if you look here, you can see that positive making a bond with the negative here. It's a very light, very easily breakable bond. And that is why ice can be broken. That is why those bonds disappear so quickly. And as you can see here to the right, I've shown you where liquid has just a few bonds inside of it, when that kind of allows that liquid to have that flowy capability, where it's able to move without, moving in different directions. And then you have the solid form, ice, where you can see all of the bonds form. And you can notice that some of the particles tend to start spreading out as a result of that. We'll keep talking about that shortly. All right, so here's your check for understanding. Go ahead and pause the video at this time and answer the question. Okay, now that you've answered the question, the answer should be A. All right, moving on. So we have cohesion and adhesion. Co meaning together, okay? And basically cohesion, as you've probably learned, is when there's hydrogen bonding between other water molecules. It's water sticking to other pieces of water. And that's what creates surface tension, like you see in this video here. Sometimes if you do a belly flop into the water in a pool or in the ocean, you get a force put back on you and it hurts your stomach, and that's due to the hydrogen bonding and the surface tension. So things float on top of water for the same reason. Same thing that works with a drinking straw. Water comes up the straw and it all holds together. Your sodas, everything else, all has water inside of it. Adhesion, similar to cohesion, holds water together, but not with other water molecules. It holds it together with other substances. And so when I think of adhesion, I really think of like plants and capillary action. I'll talk about that here in a second. All right. So cohesion and adhesion work together, especially for plants, and this is a really big concept that you'll need to know in the coming years. Cohesion, as water is sticking to other water molecules, and adhesion, where water is sticking to non-water molecules. So as you can see here in this really nice diagram, the water molecules are sticking to each other through hydrogen bonds, but they're also creating hydrogen bonds with other surfaces. And so water, as it moves up the root of a plant, kind of creates bonds that it can hold on to the roots and start moving up and up and up and up. It's just kind of how it works. This is called capillary action. Okay. So if you need to pause, make sure you get all of this down. Rewind if you need to. Right. You can see here the different colored plants. This is the same thing that happens. If you were to put a white flower inside of water that has food coloring, it will eventually soak up the food coloring due to this property here. Okay. So water as a universal solvent. Water as a universal solvent is due to its polarity, and basically what that means is that that negative part of the oxygen in a water molecule and the positive parts of the hydrogen, they push against each other. Okay, and because that hydrogen or that oxygen is bigger, it's going to pull more towards the top, and so you can kind of see that here, where it kind of makes this bent shape. That's due to its polarity. Okay, and so if we go back, I'm sorry, I'm scrolling through quick. All right, if we understand that because of this polarity, water dissolves a lot of different things. So let me show you how that works. So we have our molecules, our water molecules here. Hydrogen bonding is occurring between them and cohesion. And then if you were to mix NaCl, which is table salt, and we put it in water, it breaks the molecules apart and forces attraction between certain pieces. You can see the pluses are lining up with the minus and the plus lining up with the minus. And so it's able to break it apart and make it dissolve within it. So hydrophilic substances, okay, are substances that have an attraction to H2O, things that don't mind being in water. This will be really important in biology as you start to learn about the cell and the cell membrane, hydrophilic versus hydrophobic. Right? And so substances that are attracted to water, do you think they'd be polar or nonpolar? If you guess polar, you'd be right, because polar molecules are able to use water molecules to disrupt and break apart other molecules and use them to dissolve. So if hydrophilic means that they have an attraction to water, what do you think hydrophobic might mean? Hydrophobic means that they don't have an attraction, that they want to get away from water, or they don't mix well with water. And so this here, all these crazy carbons and hydrogens and everything else, are going to become, again, very important later on, especially in biology, when you start to learn about the cell and how they don't let water pass them. And so the best example of a hydrophobic substance, right here, oil butter, things like that, they have a lot of fat in them. And usually fats don't mix with water. That's why if you pour water in oil, you'll see or oil in water, you'll see the oil sit on top of the water. So hydrophobic substances are nonpolar. They don't have the ability to be broken down by water. Okay, so your next check for understanding: which solution cannot be dissolved by water? Take a pause the video, and answer the question to yourself. Okay, the answer here is C, oil. Everything else can be dissolved by water, but oil will always sit on top of the water. It cannot be dissolved. All right, so our fourth property of water, expansion upon freezing. Some of your questions here on the second day of digital learning was about water and how it helps us, or how freezing water applies to whole life. And what we said was that ice, when compared to liquid water, is much less dense. And so ice floats on top of water. And the reason for that is, as you can see here, when it starts to form hydrogen bonds, liquid has some hydrogen bonds, and if you remember that slide way back at the beginning, liquid has some hydrogen bonds where ice or solid has many more hydrogen bonds, and they kind of like force them to spread out. If you can see, they have this nice crystal-like shape where this over here, they're all still kind of close together. And so as they spread out, they take up more surface area and they have less density. So it's important that ice floats so that oceans and lakes don't freeze solid. Okay. Usually up in the north, in the wintertime, the top of the lake will freeze and it insulates the water below, so it lets everything continue to survive. If ice didn't float, if the hydrogen bonds didn't exist, then the whole lake would freeze and everybody or everything in the lake, ocean, everything would freeze up and die. Okay. So as you can see, the hydrogen bonds again making the ice spread apart. The molecules are spread a little closer, even more closer, and this is why ice is able to float. Again, you guys can rewind or pause if you need to. I know I'm moving quick. All right, so the ability to moderate temperatures was the last property of water, and this has to do with its specific heat. And so specific heat is the amount of heat that it takes to raise water 1 degree. And the thing we need to know about water is that it resists changes in temperature. It really doesn't like to change temperature unless you add a lot of heat to it or take a lot of heat out. And so it has a high specific heat, takes a lot of energy to heat it up. And so because of that, it moderates temperatures on Earth, or it kind of makes it so that certain places don't become too hot or cold. And what that means, if you've been to a coastal area, like Florida, we live in Florida, if you get closer to the beach, usually you get that sea breeze where it feels cooler, versus if you're inside, like towards Orlando or Gainesville, it gets very hot over there. There's no breeze from the ocean to cool it down. Okay. And so as you see here, the high specific heat, it takes more energy to heat up the water than it does the land. And so the further you go inland, it's going to get really hot, but the closer to the water you get, the cold ocean water is going to keep this area from getting too hot. Okay. So there is a question on your wrap-up that you will need to use this to answer. I've also put this question inside the wrap-up. I'm not sure if you'll be able to see it, so I left it on here. You can pause this part of the video so that you can use this during your wrap-up. Okay, notice that we have San Francisco here and we have Wichita here. There's different temperatures and you need to explain why. All right. Thanks for a great lesson. Sabo out.